Sorry about that. Yeah, I was rehearsing with Copilot and I didn't realise it like saves the slide timings in there, so watch out for that one. Today I just want to talk a little bit about some of the challenges we've seen integrating large numbers of different third-party packages into one overall facility. Just shout out to Vince from Wood that's helped me put this together. We've been doing a lot of work with them, so here we go. Quick disclaimer, I mean, this is just meant to be a discussion topic, a bit of general information, so. Okay, so what is the problem I'm really talking about? So firstly, I think we should all just recognise the fact that integrating 20, 30 different third-party packages into one system, having like good cyber resilience across all of it is extremely difficult. You've got your overall DCS, but the smaller third-party packages can be extremely challenging. And what we see is most vendors come to us with, they have a typical sort of standard legacy PLC design, and modifying that at any point in the project usually has, it's difficult. There's the typical budget, schedule constraints. On top of that, when you look at the system as a whole, you might have your main integrated control system. They typically treat all those smaller ancillary systems as just one external threat vector or one security zone. But for us as an asset owner, we really want to have a much more granular understanding of exactly the risk in each individual small package. It might be something very small, but compromise of that little system can have the same impact to our business as compromise of your larger DCS type systems. To make things kind of worse, often we see commercial agreements are in place, but long before you really understand the risks of that particular facility. And before you can document what the appropriate cyber controls are for that particular package. And I probably don't need to explain to anyone in this room, but attacks are increasing across the world. I think the sophistication in OT specifically is on the rise. Bad actors, I think, more and more are just targeting the OT environments once they get inside because they know the amount of disruption that can have and, potentially a bigger payday at the end of it. So some of the things we see are unmanaged firewalls get thrown into the overall control system architecture as some quick way to apply some level of segregation, achieve some level of cybersecurity compliance, but really the amount of protection I think that gives you at the end of the day is questionable at best. And the thing I'm really passionate about is what about the other controls? So this tends to neglect things, simple things like physical security, how you manage identity in those networks, are you monitoring the networks? And often that sort of approach of us and them, segregation in the middle, it often neglects the controls that are appropriate internal to that small package, which, like I said before, could have the same consequence to us if that's compromised. We also see a high level of just unmanaged network devices in general. There's definitely some benefits or obvious benefits to this. It's simple. Any technician out in the field can easily replace some unmanaged switch or whatever device, but unfortunately we see it just more and more in some of the most critical environments coming with equipment like this, which unfortunately having no visibility or management of that also brings in a high level of vulnerability. And remote connections, yeah, we've already talked about this a little bit today, but this is like an area I'm really interested in because digitalization is great. Everyone wants to work remotely. I mean, I've made PLC changes remotely all my career, sometimes 3 or 4 o'clock in the morning in bed type stuff. But it's just, I think, getting a bit unmanageable at the moment. It seems like you might have, 20, 30 different packages and almost all of them want to have their own bespoke remote access method. So for us as an operator, I'm not saying that any one solution on its own is bad. It's just for us it becomes unmanageable. How can you keep all of those systems up to date? How can you even understand where your risks are with all of them? And as we know, especially in OT, I think that's probably one of the most common entry points into a OT environment. So I'll talk a little bit about that a little bit more about that in a minute. So what's our approach? Nothing here is groundbreaking. I think it's just good basics, which we've talked about as well. You need to have upfront cyber specifications specific to OT early in the project. But I think one thing I've personally learned on one of the most recent projects is you really have to tailor that depending on who the target audience is, because everyone's at a different maturity, every different organisation. You're dealing from massive vendors that are used to, or integrators that are used to these types of challenges, to like some small factory that's just making one little pump skid, and they've done it the same way for the last 30, 40 years. So you really need to tailor those requirements so that you can be confident that they're understood. But you can't just stop there at the start. You have to really keep that engagement going throughout the project. And what we've seen works is having those conversations early, even before any awards are made, so everyone's on the same page about what they need to deliver. And I'm very passionate about having cyber-specific factory acceptance testing. Also spoke a little bit about that today. And all your design reviews should include a cyber component as well. Now for us, risk is what it's all about, I suppose. Why are we doing anything? It's about minimise the risk to the business. And we're not naive in thinking that we write the specs, given to the vendor, job done, they're all going to be met. We know that there's going to be deviations, lots, many. Depends, what phase of the project you catch something, whether or not it's going to be realistic to fix it or not. So we risk assess each system at like a system level, and it's just about identifying what those non-conformances are so you know about it, and then just ensuring that the risk for that particular system is tolerable. If not, should you consider any other compensating controls? We're also working hard to try and push standardisation across the facility. This is probably the hardest thing, but we try and mandate standard network hardware, standard even PLC hardware where we can. Definitely want to encourage the use of managed firewalls and switches across the whole facility. I think the biggest one with that is we used to be able to, I think, just rely on preventative controls, segregation, firewalls here, and think the job's done. Whereas these days, I think everyone's of the understanding that it's not a matter of if you get compromised, but when. So having that data or information coming back to the SOC and being able to actually take proactive actions like segregating this part of the network or just having visibility of what's going on in your environment is just critically important in today's world. So when it comes to isolation, we don't just stop at like the level 3, level 2 purview kind of levels. We're really micro-segmenting at every layer throughout the whole facility. And, paying special attention to those networks which are highly critical, like your safety system, making sure that they're extremely separate from your highly vulnerable networks like your remote access. We also talk a lot about hardening. This one, I'm interested in everyone's feedback later on, or catch me for a conversation in the hallway, but we talk about hardening, and it's impossible to have a spec that kind of says this is how you harden every single device in the universe, because there's millions of them. So we really rely on vendors to understand, I guess, the principles of just secure by design, secure by default. So that's really important to us. On top of that, physical security often gets missed, so we focus a lot on physically locking cabinets, racks, even disabling ports, and we've got processes offshore to be able to, you've got to do X, Y, Z before you can get the key to even plug something into an Ethernet port, fiber port, as an example. And remote access. This is the biggest one, I think. I spoke about how everyone wants their own remote access tool. I can't remember who it was, but brought up the rubber ducky in the compressor package. I've seen it 100 times. The way we're going to deal with that is we spend a lot of time and money developing one secure remote access solution, but it's not just designed for us to use, it's designed for external people to use as well. And I think that the goal, which is working relatively well, is if you make that option available, as secure as possible and easy to use for all the vendors, and you open it up to them, it kind of erodes the business case to have anything else. So that's the way we try and deal with that one. A couple more proactive controls. Continuous network monitoring is just so important these days. I kind of spoke about it before, but you need to be able to detect unusual things happening in your environment. But there's a lot of work there to kind of integrate that into your overall facility. Where do you get visibility? Do you get it down at the third-party package level? So that's something that it also needs to be part of the specs at the start of a project. Where do you want visibility? You kind of need to decide that when you're at the conceptual level of a project. Application allow listing, I've put that's under proactive, I guess, because you're proactively enabling what should be allowed to run. Kind of the same as hardening, but I think in today's world, your traditional anti-malware, antivirus is 30% efficacy rate or something like that. Whereas, proactive allow listing gets you a much higher level of coverage. We also have a few procedural controls, like how we manage people that come in through the remote access tool, but also how people even come to site, how they use their vendor laptop if they're allowed to, how they manage portable media on site as well, how they follow the change process that we use. All of this stuff all forms part of that overall sort of proactive monitoring type of stuff. And finally, you just have to display good cyber hygiene. Update your firmwares, update your software. A lot of people shy away from it in OT and think that I'll argue with Brad about this one, but the impact of doing something is not as bad as doing nothing. It depends. It depends on the facility. It depends on the maturity of the environment. But I'm a big believer that it can be done with the right planning. Managing your vulnerabilities, just know what they are. Give them a contextual risk score that's relevant to your business. Don't just use the number that the score that you get given. Make it relevant to your process and where you actually have that equipment in your environment. So that's really it on us managing third-party packages. I hope that sparks a bit of conversation and some more questions on the panel, but I thought I'd leave you with a few thoughts for the future. And I'm glad that one of these has already been brought up, but just the amount of documentation you have to get through, regulations, even understanding your own internal standards and then applying them to a design is, it's a big burden. So having AI play a bit of a part in that cyber risk assessment compliance review process would be pretty cool. I'm also a big believer in more automated detection and response, even in an OT environment. Everyone has the same constraints as me, I imagine, with people, money. It can be done safely, I think, but I think logically that's the next step. And finally, wouldn't it be nice where every project had cyber considered before any contract was ever signed? That's the dream. That's it. Thanks for your time.